mentioned this morning when we introduced the new Embedded Vision Alliance Research Advisory Board that Professor Roberto Manduchi from U.C. Santa Cruz is one of the members of the inaugural Research Advisory Board. We're really pleased to have him involved, already contributing tangibly to helping us strengthen the program for the 2016 Embedded Vision Summit. So thank you very much for your help there, Roberto. And I also was really excited to hear Roberto talk about his research work at the university on assistive technology for the visually impaired. One of the products that I've found most compelling in my wanderings around various conferences and websites looking at vision-based products is a product by an Israeli company called Orcam, which is in fact a computer vision-based aid for the visually impaired. I've been really fascinated by that, and Roberto told me it recently went on sale in the US, so it's good to see that such technology is reaching the marketplace. And I think Roberto's perspective on the need for such technology and challenges and trade-offs in designing and deploying it is really interesting. So thank you very much, Roberto, for being here. Please take it away.
Thank you, Jeff, for the introduction. Thanks for inviting me here. I'm very happy to be right here. In fact, when I can step out to the Ivory Tower, it's always a pleasure for me. And I do that very often because besides teaching at U.C. Santa Cruz, I also consult for a company here in Palo Alto on range sensing, and I am on the advisory board of two other small companies. So let me first tell you a little bit where I come from. See if this works. So in my previous life, I was not a professor. In fact, I worked for Apple Computer many years ago, at the time when Steve Jobs comes back. Some of you might remember Gil Amelio and all of the things that happened. And after that, I worked at the Jet Propulsion Laboratory down in Pasadena around 98 to 2000, a long time ago. I was part of a machine vision group. We were working with robotics, and we were basically, interested in autonomous navigation. And you can see probably from the color of the robots that we were dealing with who the sponsor was. Now, these robots are all different types. This was even before the DARPA Grand Challenge that some of you might be familiar with. Now, what is a common characteristic? Well, all of these robots were full of sensors, of course. We had all sorts of sensors. Cameras, stereo cameras, color cameras, infrared cameras, the first lidars out there, radar, etc. And the sensors were out there to detect obstacles, to detect terrain cover, and to make sure that the robot was able to go where it had to go. I moved to UC Santa Cruz in 2001, and as a faculty member, I had some more freedom to choose what I wanted to work on. I had always been very sensitive to issues with disabilities, so I thought, hey, we are teaching robots how to see. Why can't we use the same type of technology to help people who cannot see? Now, it's much easier said than done. We always had to be very wary of the engineer that starts from the solution in search of a problem. And so I see in my career, working on these, of course, I started being part of lots of committees, and actually I'm a standing member of a study section of the National Institute of Health, which means that I review way more research proposals they would want, and I see a lot of these engineers that really start from the product and say, well, I'm sure this could be a solution for something. That's not the case. So as part of this trajectory, I made friends with a lot of blind people. I tried to understand exactly how they live, what it is they really might need, and how technology could help. And I did a lot of missteps, and I'm trying to understand what the right problem is and to solve it as best as I could.